Hello, Richard. How you doing?
Good afternoon, everybody. I'm doing well. And I think we here at Accedian get the award for the absolute worst title of a presentation. So apologies for that. And I want to say thank you very much. I managed to dial in just about a half an hour ago. I'm based in Colorado, and I caught most of Matt's presentation there. Fascinating stuff. And I'm going to link it directly to the terribly titled presentation that I'm going to do here today. Essentially, everybody, we at Accedian want to talk to you about the less sexy side of all of this. There's some great opportunities that are being opened up around the world by 5G technologies and edge technologies in particular. But with every great advancement and opportunity, there are some folks out there that are going to want to take advantage. And we want to talk a little bit today about the security implications of some of the things that Matt was talking about and some other industries that will capitalize on both 5G and 5G edge. All right, so the three primary challenges with security at the edge. First, we have a complex, extremely complex architectures, multi-vendor, multi-operator, multi-cloud, as we in the marketing side of the house like to say, massive multi. There's no consistent ecosystem either at the edge devices themselves or even necessarily in the edge locations that they're being run in. So you have a complex, heterogeneous situation that needs to be dealt with. The second one is observability. So that does tie to the title that we had in the presentation. You have to be able to get to the right data, and it has to be rich enough to do both behavioral analysis, which I'll come to in a few minutes, but also to give you forensic, the capability of doing forensic audits. Now, what does auditability mean? Some or many of you are probably aware that the risk and insurance industries around the world essentially back pretty much everything that we do in the commercial world. And in applications where critical messaging is moving from point A to point B, the ability to know when a particular message went from one device to another device and have an audit trail for that is critically important in regulated and sensitive applications. So I'll come back to that in a little bit, but a really important is not just the ability to detect threat activity, but to actually have a forensic trail of what happened. And I'll come to why that's so critical. And then again, finally, doing the right analytics on the right data, behavioral based, as I've said, versus only signature based. That's not to say that signature isn't useful. It very much is, and in fact, it acts like a pre-filter, so you can eliminate all the script kiddies and other folks that are utilizing off-the-shelf tools, etc. We have a lot of folks around the world that if you're not aware, you can go to the dark web, you can download a tool set, and pretty much anybody can execute an attack or a spear attack, etc. However, when you do that, you're using tools that have been used multiple times before, and as a consequence, their signatures are well recognized in most tools. It's the new ones that are the problem. All right, so I am sure that none of these statistics are a surprise to anybody on this call. You can't open a news report, you can't analyze any security situation without realizing that the volume of threats is skyrocketing. We all saw the recent Garmin attack. Many folks out here, I'm sure, professional runners. Garmin was taken out for almost a week completely, and is still bringing systems back online from a malware attack. And in particular, IoT devices are a massive target for hackers. So it's risen almost 50% year over year, and that should cause all of us to have pause when we think about putting these massive IoT systems onto 5G and edge networks. When we realize that those IoT endpoints can't run, like the normal, we're all familiar with endpoint security solutions. They tend to be quite heavyweight, and your typical IoT device, I'll reference Matt's presentation, right? So they were using, I don't know if they were Canons or Nikons, but they were using cameras directly connected to a 5G modem. That camera has a Bluetooth connection to it and is very compromisable. And that camera cannot run a security solution. So if you're not watching the wire, you create an immense threat surface for hackers to go after. And they're going after them. That's what the statistic tells us. The other thing, 61% of organizations have already experienced an IoT security incident. Whether we hear it or not, it's not a question of if, but simply when an organization is going to experience an IoT security incident. And 5,200 devices are being attacked per month. I actually don't think that those statistics necessarily agree, but Symantec is seeing within their own systems a very significant increase in IoT device attacks. So I think it's fair to say that the IoT threat surface and its IoT of a variety of different forms that is one of the promises of 5G is something that we need to attend to as an industry. The other dimension that complicates this, sorry folks, my computer is not quite responding this morning. The other thing that complicates this is that for rich experiences like Matt was talking about, sure, doing a football match broadcast is a BT specific application. So that allows BT to really focus only on their own infrastructure when they're doing that. But when you think about edge and 5G experiences that are crossing multiple operators, if you assume a augmented reality application, or perhaps more importantly, one that's near and dear to my own heart, is level 5 autonomous driving. Now, there's a running joke about autonomous driving because the title itself tells you it doesn't need a network. It's autonomous, therefore it doesn't need a network. And when you think about it, your average Tesla is like a rolling data center, right? There's GPUs, CPUs, there's a ton of processing horsepower in there. And each iteration of the control systems in these vehicles is getting faster and faster and faster. And why? Because, within their visual field, they need to react in real time to threats that they identify. I can say with great confidence and authority that a Tesla, and I'll ask everybody to just picture a situation in an urban center. You have a Tesla going down one road, and you have a lorry or a Mack truck coming at 60 miles an hour that's out of control down another road, but the Tesla can't see it. And I can say with authority that once that truck enters the visual field of the LiDAR system of the Tesla can stop in time to save passengers most of the time. However, that experience is going to be extremely negative for the people inside of that vehicle, okay? Because by the time the truck comes in the visual field, the vehicle will have somewhere between 20 and 100 milliseconds to respond. That means you're going to be experiencing severe G-forces, people are going to be slammed, et cetera. Pedestrians might be at risk. For level 5 autonomous driving, we will have to have an information system that creates essentially like a radar screen for autonomous vehicles so they can see the threats that are outside of their visual field. This isn't a maybe, this has to happen. That radar screen will be built on IoT devices. whether that's cameras, whether it's sensors in, on scooters, even to a certain extent, pedestrians and their phones will all contribute to building this threat sphere for these vehicles. Guaranteed, this is going to be 100% an attack surface that hackers are going to go after. And they're going to go after the weak spot. And like we discussed already, those IoT devices are the weak spot. Again, reinforces the need for a wires-based security model. And it also, particularly for autonomous driving, reinforces that we need a common model across operators, because autonomous vehicles will have to be able to move from network to network. Massive multi. Okay. I think I've talked about a lot of this already, but the data that we collect, or that's required to be collected in order to execute a security solution at the edge for these IoT devices, has a series of characteristics which are really critical and aren't necessarily obvious. You need to be able to observe all connections. So, to a certain extent, by definition, being on the wire means you are going to observe all connections, but the system itself has to be powerful enough to do so, to see and track all communications that are happening on the wire. You need performance and KPIs as well, particularly for auditability purposes. Timing measurements are crucial. Now, if you think about that autonomous driving example that I was talking about, these are transactions that are happening in 20 milliseconds or less. There aren't that many systems out there that can process at scale without, if you see a little piggy bank in the bottom right corner, that can do that level of timing accuracy and be economically viable. That is a really tricky design challenge. Granularity, you have to have the opportunity to look extremely narrow for certain applications and then be able to bring a data reduction model as you move higher up inside of the network. High def, okay, we've talked about this before, and fundamentally it has to be operationally feasible. If you think about the volume, just assume in any urban environment that you have a 100-to-1 ratio of IoT devices to end users. That's probably extremely conservative, but just at a minimum, assume that kind of volume. When you're building a security system, and for most of the folks on this call who are into security, these concepts will be very familiar, but it's not good enough just to have the raw data, but you have to do analytics on that data. You also have to turn that data into events, and then you have to turn events into incidents. And only at the point in which you're at an incident and you're trying to figure out what's actually happened, do you want to involve humans? So the other levels inside of the system need to be automated. What does automated actually mean? It means the implementation of machine learning and AI technologies in order to bring the right information to those security researchers to make the right remediation actions. This can also be closed loop automated through SIM systems, but I'm not going to get into SIM systems for today's talk. Plus, it's way too early in the morning in Colorado for me to talk about SIM systems. All right, that was a little plea for patience. All right, next gen intrusion detection with network traffic analysis. We really do great titles here at Accedian. All right, very quickly, I want to talk about the difference between a next-gen behavior-based IDS. So when you think about what I've been talking about, you have a halo system that's watching all transactions on the wire. It's processing every single TCP transaction that's occurring on the wire. And what it's essentially doing is it's looking for abnormal traffic patterns or behaviors as opposed to what the IoT device, just as an example, should be doing at that moment. We'll use the MAT example from BT again. The idea that that camera should only be communicating with the control system or the production studio that he was referencing. If suddenly there's a transaction between that camera and a IP address that's in Uzbekistan, as an example, that's a sign that something maybe is awry. A next-gen behavioral IDS does both signature analysis, patterns, as well as watching behaviors like I just referenced. The other thing that's important to notice, and you'll remember I talked about script kiddies. If you guys aren't familiar with this concept, go and take a quick internet search. Be careful what you search for though in this space. Script kiddies, these are folks that again are downloading packaged tool sets to execute attacks. 90% of those signatures have been matched already and are relatively trivial to block. Unfortunately, the vast majority of attacks are using unique strands. So more than 68% of attacks are using unique strands. Over 80% are only used one time. So these are zero-day vulnerabilities. You may have heard that. And the other thing to remember is absent a next-gen behavioral-based IDS, the average dwell time inside of network infrastructure is around 280 days. Just think about what can be done in that kind of time frame to your network and your customers' traffic. This is a really critical component. Should be obvious, but just to state it, in order to do what I've been talking about, you need to look at the full stack. And so it also needs to be real time. You can't post-process the information, you can't stream to disk. You need to be generating security alerts in real time at a highly granular level. You remember I talked about that economically feasible concept? This is very difficult to do. It's relatively easy to describe, very difficult to do. You'll hopefully will appreciate this graphic. I'm not sure what street corner this is. However, this picture just wants to get across the idea. It's not only what you're looking at. In this particular picture, in case it's not obvious, the police officer is watching this car that crashed into the other parked car here on the street. Meanwhile, right next to him, a bank robbery is in progress. So this is the idea of perimeter-based. So when you have perimeter-based IDS or firewalls, you know, they're kind of looking at what transits them, and they're looking outside. Meanwhile, the attacker has already penetrated your network. You may ask how. If you're not familiar with the space, 80% of these kind of hacks are actually generated using credential stuffing. What does that mean? They go out and they grab legitimate credentials, and they log into network infrastructure inside of your network as if it was one of your users. That's the vast majority. That's why, you know, email phishing attacks, spears, all that kind of good stuff. That's how it works. They grab your credentials, which means they bypass all your firewalls and all that kind of good stuff. Yes, you can whitelist and blacklist IP addresses, but to be honest with you, it is trivial to hide and mask your IP address. So you cannot assume that a perimeter-based security system is going to do what you need it to do, especially when we're talking about critical infrastructure. Again, think about the Mack truck. I want that visual image stuck in everybody's head when we're thinking about these systems. I think I've talked about this a great deal, but we need to ensure that we have an uninterrupted flow of audit data around what has actually happened. Regardless of the industry, you know, whether it's massive manufacturing, whether it's autonomous V2X, V2V, et cetera, you need high resolution detail for audit. This will make a lot of sense to the folks that have to deal with risk on the call. Really important that a system that you put in place gives you not only the ability to detect threats and shut them down, but also tell you exactly what happened. Vitally important from an insurance and risk perspective. So how does this all kind of come together in the construct of what we all do here, which is we build, execute, and manage 5G cores and RANs with these incredibly powerful edge data centers that allow us to do things in a public WAN that were otherwise impossible. Just a little side note, one of the ways that I describe to people, like my own family as an example, who have absolutely no idea what I do for a living, I tell them that, you know, they ask me, why does 5G matter, right? Who cares? Like, what's another G, right? You know, et cetera. What I tell them is, I said, 5G is really the first time that a public wide area network can operate at human sense speed. What does that mean? Matt referenced augmented reality as one of the use cases. If you study this area at all, augmented reality requires that the round trip delay between when your visual field, so you just say you're wearing the glasses, you're looking at something, there's cameras in your glasses, that's being fed back to a data center. The data center is processing what you see, superimposing something on top of it and sending it back to you. I mean, that's a super basic explanation of what it is, but that whole process has to happen in less than 20 milliseconds. At that point, the low-level network performance has to be several orders of magnitude better than our current mobility networks. So 5G is the first time a public WAN can operate at human sense speed. Creates great opportunities, but it also creates fantastic challenges. We've talked about many of these. We need observability. I've talked about that. Monitoring. You know, to make these applications work, you need a high performance assurance system. It's not the purpose of this talk, but in conjunction with a security system, if you're pulling full stack information for security, you want a system that allows you to use that same data set for performance management. It's that's incredibly important. Analytics, we've talked about already. You need to do machine learning and AI. None of this can be done by human beings. It's not simply about collection. You need to analyze. We talked about security and auditability as well. So very briefly, quick plug for where we sit inside of the ecosystem. You know, Accedian's working with, oops, I guess I have to change my slides over here. My bad. Accedian is working with the leading mobile operators around the world right now in building the kind of auditability and security systems that I've been talking about. Without getting into a tremendous amount of detail, our sensor technologies, again, they have to be economically viable, extremely lightweight, the ability to do real-time KPI signature analysis, without a heavy footprint on the end device. We're embedded inside of the ecosystems that are being deployed in the edge data centers that allows us to execute the protection systems that I was talking about earlier. It's a very exciting space. You know, again, my kids only get excited when I tell them that we're going to make Teslas work all on their own, but that's really what we're doing, and it's a fantastic space, and I think we're going to see an explosion of value generation on the part of the service providers, which I don't know about everybody else on this call, but you know, I've been working with SPs for the last 23 years, and you know, it's more than high time for the value of what gets done to be attributed to the place where the real work happens, and the real work happens in the infrastructure. As I like to joke, executing code that does swipe right, swipe left is a very different and wholly simpler action than trying to manage a physical layer network, okay? Just for the record. We can talk about that another time if anybody's interested.
Richard, that was interesting. And we've got a couple of questions that kind of really lead on from what you've just been talking about, infrastructure and so on. They're from Patrick, and he's saying, in these MEC use cases, you're liable to have a telco, a cloud provider, and the enterprise itself, as well as in some cases, a separate systems integrator. So how do you see and how do you approach the shared responsibility model of the cloud providers concerning these MEC use cases and how they're going to evolve?
Well, that's a fantastic question because it leads directly into the chart that I just flipped over to next. I don't know what Patrick's surname is, but I owe him a big thank you. Really, what's critical to all of this is a common trust model. So common trust models, so like as Annie had introduced me, Chief Strategy Officer, Chief Marketing Officer. So when I put my marketing hat on, we call it a common trust model. The idea here is, and I haven't actually mentioned this, the system that you employ to do this Halo wires-based security model has to be capable of instrumenting the entire hybrid cloud universe, okay? So much of what we have been talking about involves the operator's data centers, okay? So their own cloud infrastructure, just as an example, doesn't have to be cloud, but their own cloud infrastructure. But parts of those workloads will be in the commodity cloud, or what I call it the commodity cloud, the public cloud environments. And so you need a common security model across all of those environments in order to be able to understand exactly what's happened. So the requirement, to answer Patrick's question, is you need a system that's capable of instrumenting all of those different points inside of the overall communication stack. The next generation enterprise, I haven't specifically mentioned it, but massive manufacturing is an area of significant growth or potential revenue opportunity. Again, that's going to be a situation in which part of the network is going to be potentially owned by the enterprise itself. So they're going to have all of these responsibilities. Part of the network will be managed by the service provider. There's a lot of different models for how this works. In all cases, there will be a transition from public to private and private back to public. So you need a common trust model in order to execute these high performance and security sensitive applications. Okay, I'm going to stop there. Are there any other questions?
Oh, yes. Another one from Patrick and then another one from Andreas. So Patrick says, in your value proposition, do you assume your data is made available to both the telco and the enterprise customer, or just the telco?
Well, that's an interesting question. I've never had that one before. Okay, so this isn't a technical question. This is actually a legal question. Technically, I'll answer that way first. Technically, we can make our data available to anybody. There's no technical limitation. Our systems are all designed with open APIs. You know, anything you can do in the glass, you can do through an API, you know, et cetera, et cetera. We offer the ability to store transactional data for essentially as long as required, and like I said, can distribute it anywhere. There's a much more important legal question in terms of who owns the data in that model and who has the privacy obligation in that model. So that last point is, in my opinion anyway, that last point is the most important one when it comes to who has access to the data. You know, because the vast majority of you are in a GDPR world. You know, it is vitally important that the privacy considerations are managed. There's no technical gap to it though.
Okay, and Andreas asks or says, auditability means comprehensively creating proof for any unusual interaction, and also the so-called legal interceptions. Is this planned for with legislation and regulation? So the auditability, or is that more about a contract between parties I think you mentioned that in relation to insurance.
Well, yeah, again, it's an interesting question. It's not a technical question. It's more of a legal environment question. And it's something that the industry is struggling with. So I really resonate with both audience members that are asking the question. If we just use the autonomous driving example, that is by definition an infrastructure project for a municipality. It's not something that's going to get simply done privately or independent of government regulation, which means there has to be a legislative framework yet to be developed, by the way, on how this is going to work from a legal perspective. Again, technically, we've already solved the problem in a sense. From a legal perspective and a data privacy perspective, there's a lot of work that still has to be done. That said, again, I tend to be a glass half full kind of guy. So I try to think of, okay, so how has COVID helped? It's really hard to find examples of how COVID has helped. One thing it's helped is a great deal of, if you think about the tracking apps, a lot of work went into making sure that those are anonymous, right? And yet give the user the ability to understand if they've been exposed. It's not hard to extend the model of a COVID tracking app to the idea of the threat sphere that I was talking about for a Tesla, right? The Tesla doesn't know the name of the driver of the truck. It just knows that there's a threat coming into its space. So if there's a positive thing, we've done a lot of work. I mean, the barrier for the COVID apps, as an example, had nothing to do with the technology. It was essentially the legislative environments in every country trying to figure out, okay, what's legal, right? What respects privacy, but also respects the the obligation of the public authorities for maintaining security and safety of its citizens. Right? These are tough balances to make.
They are tough. Richard, that was really very interesting. We're going to move on now, but there's just one more comment really from one of our attendees. Eugenie says, and to complicate things more, there are also legal requirements in some countries not to mix wholesale and retail customer data. So, as you say, it's not the technology that's the challenge. Often, it's the regulatory environment. Thank you very much indeed.